No.
Yes, Venkat.
Okay. So let me quickly start sharing my screen. Are you able to see my screen?
Yes.
Yes, sir. Yes.
Okay. So today our agenda is to discuss about BigQuery, Google Cloud BigQuery. But before going to a BigQuery, we need to understand few data warehousing concepts. Then only we can understand a BigQuery. Okay. So for that, before proceeding to the BigQuery and what is BigQuery, what are the features of BigQuery, so I just want to have a quick overview on the data warehousing concepts. Okay. So let us quickly understand what is a data warehouse first. Okay. What is a data warehouse and what kind of data models we have in the data warehouse and what kind of data loading strategies we have in the data warehouse. Okay. So let us quickly understand that part. So, and then we can very easily understand BigQuery. Okay. So there is nothing complex about BigQuery. It's all about writing SQLs and understanding its architecture. So before understanding its architecture or before introducing BigQuery to you, I will quickly walk you through the data warehousing concepts. Okay. So now let us quickly understand what is a data warehouse. So anybody can answer what is a data warehouse? What is the data warehouse, guys?
A data warehouse is a storage system which stores only a structured data.
Okay. Okay.
Data warehouse contains structured data that has been cleaned and processed.
Okay. Okay. Database also will store structured data. What is the difference between database and data warehouse?
It can hold a huge amount of data.
Okay. Okay. Fine. So I think we have discussed this concept long back. Most of the people forgot this. Let us quickly understand. Okay. So I have multiple database systems. Okay. Yeah. Okay. So I have multiple database systems. So what is a database? Database is a software. Database is a software which will be utilized to store, manage, manipulate our data. Okay. And we call database is also a relational database, and relational database also called as OLTP system, online transactional system. Okay, OLTP system, and I have multiple OLTP systems which are getting operated by application layer. So we have discussed these things long back, guys. Try to recollect. Let me quickly go there. See here, understand this. We have already discussed this concepts in the beginning of our sessions. Try to recollect. Okay. So we have application layer, and this application layer is responsible to operate with this own online transactional systems. Okay, online transactional systems. And then, because this application layer should work properly, what we do is we don't overload these OLTP systems. We do periodical data pull from OLTP systems, and we'll ingest data to OLAP system, which is actually data warehouse, online analytical processing system. Okay, a database is a software which can be utilized to store, manage, and manipulate the data. Okay, and the same software will be utilized for data warehouse as well. But what is the difference between this database and data warehouse? Database will be utilized to serve the application layer. Data warehouse will be utilized to serve the business intelligence. Be very, very clear. Okay. And how you will define the data warehouse? Data warehouse is a central repository. Data warehouse is a central repository to store the processed data from historical to current. Database or OLTP will store only the current recent data. Be very, very clear. Data warehouse will be utilized to store historical as well as current data. And database or OLTP will be immediate to the application layer. But data warehouse will be the immediate to the business intelligence layer. What is the purpose of business intelligence? Business intelligence will be utilized for the better decision making for my business. Okay, so now in this data warehouse platform, you can load data, historical data, hell lot of data, enormous amount of data you can load. With respect to volumes, your OLTP systems will be having very less volumes of data, but your data warehousing systems will be having very huge volumes of data, because the data is getting collected from different OLTP systems. Okay, so now the data is getting collected from multiple different OLTP systems. So, and also it is a periodical jobs. These are periodical ETL jobs, extract, transform, load jobs, right? So every day these jobs will get triggered, or else every week, or else every month, depending on the schedule, these ETL jobs will trigger, and then they will pull the data from the OLTP systems, and then they will load it into data warehouse system. Guys, still this concept, are we clear? I just recapped our existing discussion. So any questions or queries here?
No.
Now define what is a data warehouse, guys. Come on. Anybody?
Um, so the data warehouse is a central repository storage system where it can hold huge amount of historical data,
Yes.
which is needed for the business intelligence to add business value.
Great. Great. So that is what the data warehouse is. Okay. Now we know what is the process of ETL. Okay. We know what is the process of ETL. Extract, transform, load. Okay. Extract, transform, load. We'll come to our advanced data lake systems later, but let us understand the basic data warehousing concepts. Then we will come to our advanced data warehousing systems. Okay. Now, ETL, extract, transform, load. Okay. So this extract, transform, load will be happening from OLTP systems or from flat files to data warehouse. Okay. So how this ETL will happen? So because we are at least matured enough to work with the database now, how this actually this ETL process will go, right? So we extracted the data, we transformed it, and we need to load it. Okay, but I have previous data, right? I have yesterday's data. So how I'm going to manage my previous data and my current data? Right, so that's where you have different loading strategies come into the picture. Okay, we call them as loading strategies, data loading strategies. Okay, so what are those strategies? We'll see one by one. Okay, we'll see one by one. So here if you see, we have the first one is full load or truncate and reload. Okay, so this is one strategy. Okay, so what do I mean by that? So let us take an example. I have table 1 in my source system. I have table 2 and then I have table 3. Okay, I have table 2, table 1, table 2, table 3. Now my ETL processing is happening. This is my OLTP system. Now my ETL is happening. So in the ETL, the logic is, so join all the 3 tables. Okay, extract or else select few attributes. Okay, this is my ETL logic. Okay, this is my ETL logic. Now once I selected all the attributes, I have data warehouse, and in the data warehouse I have table C. Okay, so now this is my ETL process now. Okay, every day this table 1, table 2, table 3 is getting populated with the fresh data, and every day my ETL job is running, and it is pulling the latest data or else all the data, and then it is loading it into table C. Now how to pull the data and how to load the data, right? So how to pull the data and how to load the data. If my ETL job is going and connecting to table 1, table 2, table 3 every day and pulling all the data from table 1, table 2, table 3, okay, pulling all the data from table 1, table 2, table 3, and then pushing it every day or overwriting that data every day in table C. Okay, let us say here you have 100 records, 100 records, 100 records, and when you do join you got 100 records. Okay, when you do join you got 100 records, and then every day you are pushing 100 records to this table C. So how we will push every day in full load strategy? We will truncate, or we will clean this table, and then we will load it every day freshly, all the records. Okay, so every day we are loading everything from the source to target. Okay, in our every schedule, our ETL job is taking the entire table 1 data, and then it is truncating table C first, and then it will load the data. So what will happen now? Every day it's a full load. That's why we call it as a full load or truncate and reload. So every day we'll pull everything and then we will override the existing table in the data warehousing system. Guys, any questions here? Full load. Any questions? Are we clear? Are we clear? Any questions, guys?
Yeah, clear.
Full load. Okay. So this is overlap. Now one strategy is completed. Okay. Now when this full load will be happening, if your tables are small, then every day loading all the data from all the tables to, or else every day refreshing uh, the final table or target table is okay, because your table size is small, your data is also low, so your full load jobs will run faster. Now let us assume you have billions of records in your table 1, table 2, table 3. Okay, then if you want to do a transformations and then load it, then it is a very time consuming process for your ETL job, right? So that's where we go to incremental load. Okay, that's where we go to incremental load. So in the incremental load, again we have two strategies. Okay, incremental load. Okay, so what is this incremental load? Let us say I have a table here in my source system. Okay, and I have ID one. Well, let us take an example. This is employee ID, salary, load time. Okay, now here I have 5,000, and then load time is 10 a.m. Okay, okay. So now assume you have a table here with this employee ID, salary, load time. Okay, now 5,000 records you have. Okay, now again after some time this record got updated with 6,000, and then after some time this record got updated with 10,000 from your application layer. Okay, so now your record is keep on updating, right? So at any point of time your target system need only assume the latest snapshot of your record. Okay, then in that case what we do, we just ingest and do incremental merge. Okay, incremental merge, and then we have another load called incremental append. Okay, so what is incremental append? Every day we'll pull incremental data. In both the cases, every day we'll pull incremental data. Incremental data meaning from start time range to end time range. Okay, so we need to talk about one more concept here called watermark. Okay, watermark. Let us take an example. I ingested today, my job ran today, and it ingested from 10 a.m. to from 10 a.m. to 11 p.m. Okay, so 10 a.m. to 11 p.m. So this 10 a.m. to 11 p.m. what I will do, I will store this 11 p.m. I will store this 11 p.m. in my watermark table. So for example, table 1, okay, my watermark is 11 p.m. along with the date. Okay, along with the date, I will store this last timestamp. Okay, so when next time my incremental job is running, it may be merge or it may be append. Next time my incremental job is running, it will go and read the watermark. Okay, it will go and read the watermark, that is 11 p.m. And then it will add hours, let us say 6 hours or 7 hours or 12 hours, whatever the hours it will add. So it will form the end timestamp. Then it will go and apply the filter on the time range. Again, it will pull the incremental data. Let us assume the next interval is 11 a.m. to 10, sorry, 11 p.m. to 10 a.m. again. Okay, 11 p.m. to 10 a.m. Then again, I'll change this watermark to 10 a.m. after my load completes. Okay, so this is how the incremental process will go. So on a incremental fashion, we'll pull the data from the source. Okay, on an incremental fashion, we'll pull the data from the source system. So similarly, on an incremental fashion, we'll load the data to data warehouse. Okay, so here two things: how incrementally we'll pull the data by using the watermark table. Okay, by using the watermark table, we can get the last load time, and we'll apply the filter on the source based on the load timestamp. In database, in the OLTP systems, every table will be having a load time, or last updated time, or last modified time. So they database designers or modelers should maintain that column for better visibility when this record came into our system, when this record updated in the system. So for that reason, they will maintain last updated or last modified column in every table in the source side. Okay, so by using that column, we will actually do the incremental load. If we don't have last modified column, then we will go for the primary key column. We'll go for the primary key column. Okay, so we'll keep on increment based on the primary key column. Let us say today I have ingested till this id, and from tomorrow I have to ingest from this id to this id, something like that. Okay, so but anyway, we have to pull the data incrementally, and we have to load the data incrementally. So this is what we need to do. So now for our pipeline, for our data pipeline, in the incremental load, watermark table is the very critical thing. Be very clear. For every table, we have to store the watermark in the incremental table. As and when the load completes, we have to update the watermark. Okay, so that we can, when failures comes in, we can go and check what is the successful watermark, last watermark. Okay, when your pipeline fails, then you can actually fix that pipeline and run from that watermark. Okay, so that is how you will do in real-time projects. Okay, so now what is incremental merge, what is incremental append? So are we clear on incremental pulling of data, how we pull incrementally? Right, every day in the full load, the disadvantage is if your table is very huge, every day you have to go and read your all data, right? And if your table size is very huge, your ETL jobs will die. Okay, so that is the reason we'll go for incremental load for huge tables. Okay, for huge tables. Okay, now you can ask a question: what happens to this source database? Because every day the data is coming, we are pulling the data, but what happens to the source system? In the source system, the data is still there, right? So how our application layer will run? Correct. So that is one more question you may get. But in that cases, what will be happening? So there will be DBAs, database administrators, for these source systems, because these are production critical. So there will be DBAs, so who will be taking care of purging the data, who will be taking care of purging the data. Purging means deleting. Okay, purging means deleting. So they will from the business owners, they will get instructions saying, hey, keep only 1 year worth data here, or else keep only 10 days worth data here, or else keep only 6 months data in the source system. So then they will go and purge. They don't know all these incremental and then loading, ETL, all these things. They will only follow the instructions given by the business owners. Now what will happen? So our ETL is completed, and here the data got purged, right? And then where the analytics will be happening? So on the OLAP. So that's how it works, guys. So now incremental merge. Now incremental merge means we have pulled data incrementally. Now how to load the data incrementally, right? So to load the data, we have two options. One is merge, another one is append. Okay, one is merge, another one is append. Just 1 minute, guys. Okay, so incremental merge meaning every day when the same record is coming, every day when the same record is coming with the updated values, then what will happen? We will merge that record. Okay, we will merge that record. I'll explain it. So here, let us say it is the initial load. Okay, fresh first load. Okay, now for in the first load, my employee ID 1 have 10,000 salary. Okay, I ingested the same to my data warehouse. Here also my employee ID 1 have 10,000 salary. Okay, now again in the next interval, my employee ID 1 salary got updated to 15,000. Okay, so 15,000. Now in my next load, my incremental ETL job will run, and it has to go and merge, meaning it will overwrite or it will update this 10,000 value to 15,000. Okay, based on the ID column. Okay, if in the merge statement, what we do, we check whether this primary key is already exist or not, and if it already exists, we will update the salary. Okay, we will update the salary. Now in the incremental merge, again we have three different strategies or two different major strategies. One is SCD1 and SCD2. Okay, SCD1 and SCD2. So what is this SCD1 and SCD2? We'll discuss in our coming sessions. So slowly changing dimensions. So for that to understand, we need to go through fact and dimension tables. So which I'll cover in our coming sessions. Okay. So before going to that, we will see what is incremental merge first. Okay. So merge meaning if we found the same ID in the data warehouse in the same table, try to update the value. That's it. Try to update the value. Okay. What is append now? So even if you found the same record, you just go and push the latest value. So that means in the incremental append, what will happen? You will have the previous record 10,000, and you will be having the current record also. Okay. So for the analytics, if the business demands the historical data as well, or else the history of the record as well, then they will go for incremental append. Okay, business doesn't need the history of each record. Business only need the latest snapshot of that record. Then in that case, they will go for incremental merge. Guys, are you with me? Any questions here in incremental merge and incremental append?
Uh, Small.
Yes.
So when we are trying to update the record, right? So is it on the basis of each column, or entire record will get updated?
No, it is
Like,
based, the merge will be basically happening on the primary key columns most of the times. So
Okay.
whatever the primary key column that is there, for example, here employee ID and here also employee ID will be there, right? So for that table, so we'll do merge operation on the employee ID column, primary key column. Let's quickly see the merge statement. You'll come to know. Okay, see here. So merge target table using source table on merge condition. When matched, what needs to be done. When not matched, what needs to be done. So this is how we will do merge in real time. Okay, so for example, I have my target table and I have my source table. Okay, I have my target table and I have source table, and I'm doing merge operation on condition. If you see here is the primary key column, department ID, and here some other column. So we are doing the merge operation based on a condition. When matched, when it found a match, then what needs to be done? Update the record, or when not matched, insert it. Okay, that means if it is record is present on which satisfies the condition, then you can go and update the values. If the record is not present, then you just simply insert the values, right? So it is completely depending on a primary key column. It is not restricted for a single column. You can put multiple and conditions here and give multiple columns based on which you can perform merge operation.
Yeah. Okay. Thanks.
Any other questions, guys? Come on, guys, ask questions. If all of you clear? Okay, let's see how you understood the concept, Anusha. So what is incremental append?
Yeah, when incremental append is nothing but like we can update the data like batch wise.
Okay, are we we update the data in incremental append, or
Like uh,
we'll add the data to the existing?
add, no, sorry, add, not update.
Okay, fine. Bablu, what is incremental merge?
Incremental merge means we need to update the data.
Okay, so update based on.
Update based on recent data.
Okay, how we will pull data incrementally?
Data pulling incrementally. When the data is latest data, we need to update in incremental merge.
Okay, we'll update in the incremental merge, but how we will pull the data from the source incrementally?
Pull the data.
Come on, guys. So we have discussed about watermark concept, right? So we have last modified timestamp column in your source system, and then every time when our job is running, we'll take the end timestamp and then we'll update it in the watermark table, so that for the next run, we will read that watermark timestamp and we will add some timestamp to it, and then we will load it. Okay, so let me explain it once more. Maybe people are getting confused, so let me explain it once more how this watermark will work. So let's take some sample data so that you will understand. So here, ID, salary, this is my source system, and I have last modified column. So in database systems, OLTP systems or OLAP systems, everywhere, the best practice is maintaining last modified column. Okay, so maintaining last modified column. So what this column importance is, it will tell us when this record came into the system or when this record updated in the system. Okay. Now let us see, I have ID 1 and salary 5,000 got inserted for the first time. And the inserted timestamp is, let us say 2024 07 30 31st. Okay. And then timestamp is 11:30 a.m. Okay, so this is my first record that got inserted into my table. Okay, where it got from where it got inserted, because it's a OLTP, there is a front end application which got inserted. Okay, this record, fine. So again, it got second record. So second record, ID 2 and 10,000 is the salary, and then timestamp is 11:35. Okay, at 11:35, this record got inserted. Okay, now record 1 inserted, record 2 inserted. Okay, now what will happen? Your pipeline, your ETL pipeline is scheduled to run every day. You're scheduled to run every day at 11 p.m. Okay, so your pipeline schedule is every day 11 p.m. Okay, every day 11 p.m. So every day 11 p.m. your pipeline will trigger. Okay, that's your ETL pipeline. Okay, so every day 11 p.m. your pipeline will trigger. Now the first run, right? The first run, your pipeline got triggered. Okay, your pipeline got triggered, and then it went to this table. Okay, it went to this table, and it needs to query. Okay, it needs to query. Your load is incremental, so you need to pull the records which falls under a time range. So to pull the records between the time range, we need start time and end time, so that we can apply a where clause on this last modified column, right? So what will happen every day? Your pipeline has to run. Your pipeline is running for the first run, and you have the watermark table here. Okay, watermark table. Okay, and then you are inserting the watermark for the first time. What you do, you update your watermark. Let us say your employee table here. What we do, table name will mention, and then what is the watermark? I'll update. Okay, I'll update 31. Okay, I updated this watermark. Okay, so now what will happen? I will try to update this watermark. So now my ETL pipeline, when this running at 11 p.m. right? So it is running at 11 p.m. and then what will happen is, starting from this watermark, right? Till till the maximum time that is there in your last modified. Okay, so what is the maximum time that is there in your last modified? This is the time, right? So it will apply the start time. So what is the query it will try to run? So the query it is going to run is select star from employee table where last underscore modified greater than or equals to this time. Okay, and last underscore modified less than or equals to this time. Okay. So this timestamp it got from the watermark. Okay. And this timestamp, how it got, it will go and first query the maximum time here. Okay. Before this executing this query, it will go and query the maximum timestamp that is there in this table. Okay. So it has the start time now and it has the end time now. Now your ETL job will run and it will load the data into your data warehouse. Assume it's a incremental append load. Okay. Now it got ingested 2 records. Okay. Now the next run, right? Now the next run. So here it is actually running for 31st, 31/7, 31/7, 2024. Okay. 11 p.m. it ran. Okay. Now it pulled all the data starting from this timestamp to this timestamp. Okay. Now next day it has to run, right? Next day it has to run. So in the 8th 08 sorry first 08/2024 11 p.m. it has to run. Okay. Now for the next day, if it go and check here, if it is not updated, right? So that is the reason every time when the previous load is completed, 31st load is completed, we will update the maximum time that we extracted here. Okay. Now we updated. So for the next day, now we have the watermark here from where to start with, right? From where to start with. So, and again we'll go here and next day, by next day, let us say you have 6,000 got updated, and then it will fall under a 018 month, 11:30 a.m., right? And then some other record got added, let us say 13,000, and then at this timestamp, right? So what happened in the next day? ID1 record got updated, ID3 record got added, right? So you have in the incremental load, what will happen for your pipeline is running for the next day. It went to this watermark table, it picked the latest watermark. Okay. Watermark meaning the previous run timestamp, guys. That's it. So till what timestamp our pipeline has run previously. Okay. So the previous load happened till here. Now you have to pick this timestamp as your start timestamp. Okay. You have to pick this timestamp as your start timestamp. And again, you need to find the end timestamp, right? So you will go and find the max timestamp here. What you will get the max timestamp? You will get this here. The max timestamp is this one, right? Okay. So when you do here, what will happen when you do this? What will happen? So it will pull the data starting from here and then till here. So how many records you will get? You will get 1 record and then 3 record, right? So then what it will do? It will go and it will add those 2 records into your data warehouse. Guys, are you following how actually the incremental data pulling is happening? So this is very important, guys. Even if it is cloud or even if it is on-premise, the concept is same. Be very, very clear. You'll be building or developing data pipelines from Oracle to from Oracle to BigQuery, assume. Okay, so they asked you to develop a incremental data pipeline, right? So how you will do that? So you should have this knowledge. Otherwise, it is very difficult for you to implement such kind of incremental data pipelines. Okay, so how we do all these things, that secondary, whether you use tool or whether you use program, it's secondary, but the concept is important. Be very very clear. You are doing it with an NiFi or you're doing it with Python, that's secondary. Okay, but the concept is important. Okay, so this is how we do incremental data pulling, right? And this is the importance of watermark table. So anybody have any questions now, or are we able to understand? Are you followed this example?
Yeah.
Again, Bablu,
Yeah.
Bablu,
Yeah, Venkat, clear. That
clear?
watermark means uh, latest modified data.
Yes,
Yeah,
latest. I
modified
mean,
date.
simply understand previous load timestamp. That's it. Previous load, last modified timestamp.
Okay, okay.
Okay,
Based
till,
on the previous and last modified date,
yeah,
data will be pulling.
yes. So the previous load timestamp also we only will update. We will pick it from the last modified only, and we will take the maximum of it every day when we are running it. We will take the maximum of it. We will take the previous timestamp from watermark, and then we will apply the timestamp filter.
Okay, okay.
See, simple guys. You have some work. Okay, you have some tasks to do. Okay, and you have 3 days of time to do that task. Okay, first day you completed some part of it. Okay, you completed some part of it, and the next day you have to start from where you left. Right, you have to start from where you left. For that, you should know where you stopped yesterday. Correct? Let us say today I completed task one. When tomorrow, if I want to start, I should know task one is completed. Otherwise, otherwise, how will I start task two? Are you getting my logic, guys?
Yes, yes,
Just map it to a small example so that you'll understand very clearly. So your pipeline also should know yesterday till what timestamp I have loaded my data. Okay, so then only today your pipeline can pick the data properly, right? So this is not a full load where we can actually go and execute select star from and then do everything every day. This is not full load, right? So this is an incremental load. That means we need to pull the data incrementally. For that, we should know from yesterday to today what records came. To know that, what is the yesterday loaded timestamp? So for that, we will maintain the watermark. Are we clear, guys? Am I confusing you?
yeah, clear. Venkat.
Anybody have any questions? Prakati, Ranganath, are we
No,
clear on the
Venky.
concept?
Yeah.
Okay, so Anusha,
No, Venki, not
understood?
really. Yes, Venki.
Okay, okay, fine. So this is how we will incrementally pull the data and load it. If it is a merge, then we will maintain only one record per ID. Okay. So if it is a append, we will add records, keep on records, even if it is duplicated, even if ID is duplicated, we will keep on adding the data to the table. Okay. So now in that case, you can ask, hey Venkat, if we keep on adding the data to my table, the data will be very huge, right? Yes, it will be very huge. And your data warehouses are capable enough to store that huge volumes of data. Okay. And what if my business needs only the latest snapshot for analytics? Then in that case, what you need to do, you need to group by on your ID column and take the latest record based on your timestamp. We know row number, we know dense rank, all these functions. We know how to apply these functions, right? Partition by ID, order by timestamp, descending, and pick the first value so that you will get the latest.
Latest.
right? So that's how we will implement the logics on top of the incremental tables. Okay, so this is what incremental merge and incremental append. So full load, incremental merge, and incremental append. So these are the loading strategies. Be very clear. In real time, these are the strategies that we will implement. So there is one more advanced strategy, loading strategy called CDC, change data capture. Okay, change data capture. So the CDC is the advanced load pattern that we are using in a uh, data warehousing or data lake systems in today's world. So tomorrow, what we will discuss is we will try to see one example for CDC load. So right now we are clear on full load and incremental merge and incremental append. And tomorrow we will see the data models, how actually the data models will be happening in data warehousing or in data lake system. What is the star schema? What is the fact table? What is the dimension table? Right? So what is SCD1? What is SCD2? These things we will cover tomorrow. Okay, so that we can finish off the data warehousing concepts, and we'll also see one example for CDC load. Okay, so that we can finish off the data warehousing concepts. Then if I talk about BigQuery, you can easily correlate. Because it's very important to understand what is data warehousing before going to BigQuery, because BigQuery itself is a advanced version of data warehouse. Okay, so what we can do with BigQuery, you need to understand before in hand. Otherwise, it's meaningless to go to BigQuery, right? So before going to BigQuery, you should have some knowledge on how data warehousing and ETL process will work, right? So that's why I'm spending a couple of sessions on giving you the knowledge of ETL and data warehousing. Okay, so tomorrow we will concentrate on the data warehousing. Today we concentrate on the ETL strategies or loading strategies, right? So tomorrow what we do, we concentrate on the data warehousing models. So what is star schema? What is snowflake schema? Why we have these data models, right? And how data modeler will design all these ETL tables, right? So we will see that concepts tomorrow, and then day after tomorrow we will be starting with BigQuery. Okay, day after tomorrow we'll be starting with BigQuery. So that's the plan. Okay, so no problem, even if it is delayed, it's okay, but try to understand the concept. Okay, so that's all I have for today, guys. Thank you so much for joining once again tomorrow.
Thanks.
Thanks.